Hi, this is Chris with Sanderson Test Prep, and in this video we are taking a look at SAT Practice Test 1, Section 3, questions 5 through 7. So let's go ahead and zoom in on question 5 and take a look at this one. Which of the following is equivalent to the expression above? So what they're doing here with the answer choices is they're finding a way to simplify this expression. So whenever you have something in parentheses, you want to look and see if there's anything outside of that parentheses that would have to be distributed. So here, for the first parentheses, there's nothing out there. You could think of it as if there's a 1 out front, and when you multiply anything times 1, you just get the value itself. So we can just drop those parentheses. We would rewrite this as x squared y minus 3y squared plus 5xy squared. So that stays as is. I'm going to just move this down here to give us a little bit more space to write. So now, for the next parentheses, this one's a little bit trickier because we have a negative out front. And just like if you had a numerical value, that negative has to be distributed to every single term. So it's just like you're multiplying everything times a negative 1. So the sign of each term in the expression is going to change. So here, negative times negative will be a positive x squared y, then a negative 3xy squared, and then a positive 3y squared. And now we have to combine like terms. So here, x squared y and x squared y, when we're adding those together, will give us a 2x squared y. Negative 3y squared and positive 3y squared, those cancel out. And then lastly, 5xy squared minus 3xy squared will leave us with a positive 2xy squared. So the key there is just making sure you're really careful about identifying which terms are in fact like terms. The variables and the corresponding exponents for each have to match for you to be able to combine those coefficients together. And when we do that, we are left with 2x squared y plus 2xy squared, which matches to answer choice C for number 5. All right, let's take a look at number 6. So here it says h equals 3a plus 28.6. A pediatrician uses the model above to estimate the height, h, of a boy in inches in terms of the boy's age, a, in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So a lot of times when working through this question, I'll see students plug in a 2, plug in a 5, or sometimes even plug in everything in between to see what that difference is per year. They'll try plugging in a 2, and then a 3, and then a 4, and then a 5. And we can certainly do that. So let's see what that would look like. This is h equals 3 times 2 plus 28.6, which comes out to 34.6. And then we'd have h equals 3 times 3 if we did it for when the boy is 3 years old, plus the 28.6, so that would be 28.6 plus 9, so that would be 37.6. And then h equals, if you tried it for when the boy is 4 years old, 3 times 4, 28.6, that would be 12 plus 28.6, which is 40.6. And then even if we went all the way to 5, and we don't have to, but if we did, I'll just put the math on here. 15 plus 28.6 is going to equal 43.6. And so then you might be able to look at this information and notice that each year, from one year to the next, we are increasing by 3 inches, giving us the correct answer of 3. And if that's the way that you approach this problem and you got it right, then great job. That's absolutely correct. But I want to take a look at another way of looking at this same problem. And you will see this very commonly where you have something that is sort of a hidden slope intercept form question. This is very common SAT-wise. We see h and a, so we don't always actively think of it, but this is really an application of y equals mx plus b, where here the 3 would be acting as our slope, and the 28.6 would be acting as our y-intercept. Now the reason that can be really helpful to identify is because the question wants to know the increase in the boy's height each year. And because it says each, if we recognize that it's each, that lets us know that we're looking for slope. And our slope here is 3, which is our correct answer. So we can actually identify the correct answer without having to do some of this more complex math that we saw over here. So if you want to find a way to avoid that, especially since it's a no calculator section and you maybe don't want to deal with all the decimals, then being able to recognize when you have a slope-intercept question, even if it's not written with your y and your m and your x and your b the way you're used to seeing it, that equation can still be representative of slope-intercept form. And if you're able to effectively read the question and find those keywords like each that let you know they're asking about slope, you can answer a question like this quickly without having to do all of the laborious math that we see over here. So that's one strategy to maybe train your eye to recognize when you have an opportunity to avoid having to do the exact math. Now let's move on and take a look at number 7. So this question is one of the most popular in this section that I'll see students look at and just automatically skip right when they get to it because it looks very intimidating. And that's certainly acceptable. When you see a question that looks intimidating, maybe it's not the best question to invest time on. However, I want to point out one thing that maybe helps keep us engaged and give this question a try. It's question 7, but we're in the no calculator section, so it's really 7 out of 15 total multiple choice questions. And the reason that's helpful is because although this question looks really overwhelming at first glance, we're only about halfway through the section. And that can maybe help us take a deep breath and say, hey, you know what, this is only supposed to be a medium level difficulty question, so maybe it's worth giving this one a try. Now, although this looks very intimidating, if we look in our answer choices, a lot of our answer choices actually show the same kinds of values that we see in the question itself. And they're maybe just, being arranged in different positions. Sometimes we see them, on top in the numerator or on bottom in the denominator. And so we're not necessarily having to simplify all of these parentheses the way we might think we would have to at first glance. So just keep in mind, sometimes when a question looks intimidating at first glance, it doesn't always mean that you're going to have to do math that's as complicated as you think. So let's try this, and I'm going to just rewrite this in a slightly different way with numbers. Because a lot of times I see students work with this question numerically and have a lot more success, and then they recognize right away what they're supposed to do with this complex looking algebraic expression in front of us. So here, instead of saying m equals this big complicated thing over this other big complicated thing times p, I'm going to simplify that a little bit. Let's look at this in a different way. What if I had m equals 2/3 p? And I said, okay, how do we get p by itself? So at the core of this, we still have to know how to eliminate a fraction when we're trying to isolate a variable. And to do that, you can multiply by the reciprocal. So however you think about it, you could think of it as dividing by 2/3, and that's the same thing as multiplying times 3/2. So if you multiply both sides by the reciprocal, you can cancel out that fraction. And when you multiply by the reciprocal, so what you would be left with is that p would be equal to 3/2 m. This is just going to be, what we see here is the reciprocal of what we started with the 2/3, right? And so if we apply that to this complicated looking question here, we can say, all right, to get p by itself, I would have to multiply m by the reciprocal, which means this complicated looking denominator would be up here, 1 plus the r over 1200 whole thing to the n and then minus 1. And then over this big complicated looking numerator would then be down here, the r over 1200 times the rest. And in the interest of time, without writing all of that out, if we look at our answer choices, we can see that if we just look at which one multiplies m times the reciprocal of this original fraction, that's going to actually match up to answer choice B. So hopefully we can see here that this is our denominator originally and our numerator originally are essentially just switching places, just like we had over here with the 2/3 and the 3/2. So without doing a bunch of complex math, we can hopefully recognize that when you multiply by the reciprocal on the other side, these two are really just switching spots. And that big complicated expression does not require us to do any algebraic manipulation of that big complicated expression in order to find our correct answer here. So that's how we can tackle a question like number 7. For more, please stay tuned and watch the rest of our videos covering SAT practice test.